Hello everyone, I'm Sebastian Y, and this is Foundations of Economics. In this set of videos, we're going to introduce perfect competition. In this video, we're going to define perfect competition and look at a simple example of how a firm will maximize profit in perfect competition. There are four main assumptions for a perfectly competitive market. Number one, there are many buyers and sellers, each of which is small relative to the size of the market. Number two, each firm in the market produces identical products. We sometimes use the word homogeneous to refer to these identical products. Number three, buyers and sellers have perfect information. These first three assumptions combine to give us the result that buyers and sellers in perfectly competitive markets are price takers. This means the price is determined by the market as a whole, and no individual has an incentive to ask for a different price, higher or lower than that market price. We say that no individual has market power. Zooming in on the firm side of things, as we will do in these videos, each firm is such a small part of the overall market that they can sell as much output as they want at the market price without having any impact on that price. Normally, with the law of demand, we think about an inverse relationship between quantity and price. For quantity to increase, price would have to come down. But our firms are such a small part of the market that even if they increase their output, it won't have any impact on the overall market price. As such, there's no reason at all for an individual firm to offer any price lower than the market price. They also have no incentive to charge a price above the market price because that would lead to zero sales. All the firms produce an identical product, and buyers have perfect information, so they would simply go to one of the other sellers. The fourth assumption of perfect competition is that in the long run, firms can freely enter and exit the market. In the short run, however, firms are either in the market or out of the market. We assume there is a necessary amount of capital required to be in the market, and in the short run, there is insufficient time to acquire that capital and also insufficient time to offload that capital in order to exit the market. The requirements of perfect competition are quite strict, and in real life, there is probably no market that fulfills all of them perfectly. Markets for agricultural commodities may come close when there are a large number of farms. Grains like wheat and corn are effectively homogeneous. There are also lots of buyers in the sense that everyone buys food. However, there are many agricultural markets where large farmers and large buyers have started to dominate the market. We're going to start our study of perfect competition by looking just at the short run. So we're going to assume that the firms who are in the market are in the market, and the ones who are out of the market are out of the market. There's a fixed number of firms. Firms are price takers, so we are going to, for now, take the price as a given. This means the only decision the firms have to make is what their quantity is going to be. A firm's goal is to maximize profit. We've defined profit before as pi equals total revenue minus total cost. In the firm's decision of how much quantity to produce, an increase in quantity is going to increase total revenue because they're selling more, but it's also going to increase cost because they are producing more. So how do we decide how much output to produce? The question we want to ask is, will our total profit increase if we increase our production? If we increase quantity by 1, total revenue will go up by an amount called the marginal revenue, or MR. This is the amount that revenue increases if quantity goes up by 1. At the same time, the total cost is going to go up by the marginal cost, which we defined in the previous set of videos. If marginal revenue exceeds marginal cost, then it's worth it to increase production because that will increase total profit. If marginal cost is greater than marginal revenue, then that unit is going to reduce our profit, and it's best to not do that. In perfect competition, remember that a firm can sell as much output as it wants at the market price P. So in perfect competition, marginal revenue equals the market price. So this tells us if price is greater than marginal cost, then we want to increase output. If price is less than marginal cost, then we should decrease output. Let's look at an example of how this might work. In this chart, I have the cost structure of a firm in a perfectly competitive market for quantities 0 through 10. We have a fixed cost of 300. That stays the same. We also have a variable cost. Fixed cost plus variable cost adds up to total cost. We take our variable cost and total cost, divide them by Q to get our average variable cost and average total cost. And then finally, we have our marginal cost column that is our change in total cost as quantity increases. For example, we can see that going from 1 unit to 2 units will be an increase of 40, so our marginal cost there is 40. To start out, let's think about what happens if the price in the market is 150. This means that our marginal revenue is also 150. I'm going to fill that in all the way down. We're now going to compare our marginal cost and price to see how much output we should produce. Looking at the first unit, price is greater than marginal cost, which means that we would make more profit by producing the first unit, so that's a go. Looking at the second one, 150 is greater than 40, and we can continue this down until we hit the 8th unit, where marginal cost is still lower than 150. It's 140 here. But if we go to the 9th unit, our marginal cost of 180 is bigger than our price of 150. So if we would have produced the 9th unit, we would decrease total profit by 30. This means that 8 is going to be our profit maximizing output. We can verify this by calculating the total revenue and profit columns. For total revenue, we take our quantity times the price. So we have 0 here. 1 times 150 is 150. 2 times 150 is 300, and so on. To calculate the profit, we take total revenue minus total cost. For the first one, we have 0 revenue and 300 total cost, so negative 300. For the second one, we have a total revenue of 150, total cost of 360, so we're going to get negative 210, and I'm going to keep filling these in all the way down. We can see profit starts out negative and increases as we increase output because price is greater than marginal cost. Marginal cost starts out low and rises, and eventually it's going to catch up with the price. And it does that right here at the 9th unit. And so we stop at the 8th one, where we get our maximized profit of 360. Let's look at another example, this time with a market price of 30. Since we already did this once, I went ahead and filled in the chart. Again, total revenue is price times quantity, and profit is total revenue minus total cost. We can see from the profit column here that no matter what the firm does, they're going to take a negative profit, which we also call a loss. This is because the price was quite low in this example. Even worse than that, the best thing that they can do is actually to produce nothing and take a profit of negative 300, which is just the fixed cost. Producing any amount of output will just dig a deeper hole for them. We can see this because total revenue never even covers the variable cost. Therefore, the best thing to do is to produce nothing, which we call shutting down. We can quickly see if the best option is to shut down by comparing the price to the average variable cost. We look for the lowest point of the average variable cost, which in this case is 40, and we can see that that is greater than the price. This means it is impossible for the firm to do better than shutting down, because it is impossible for their revenue to cover their variable cost. Sometimes the price can drop below average variable cost for a firm due to seasonal effects. If that's the case, the best thing they can do is temporarily shut down, continue paying their fixed cost, until the market price rises back up again, when they can start making a profit. One example of this might be an ice cream stand that shuts down during the winter because there's very little interest in going to an ice cream stand when it's cold out. Once the weather warms up, the demand curve is going to shift to the right and raise the market price back up. But during the winter, they're better off staying closed because it's unlikely that the little sales they could make would be able to cover their variable cost. Let's look at one final example where the market price is 70. This is quite a bit higher than the price in the last example, such that it is higher than the minimum of the AVC, so we should not be shutting down in this case. However, it's still not high enough to make a positive profit. After we determine that we should not shut down, we should then go about our normal process of comparing marginal cost and price. We can see that the price is greater than the marginal cost up to the 5th unit. If we go to the 6th unit, we're going to end up losing a profit of 10 on that one. If we go to the 6th unit here, marginal cost is 80 compared to the price of 70, so we would lose a profit of 10 on that unit. This means the best place to stop is the 5th unit of output. We can see from the profit column that is in fact the highest number here. It's still negative, they're still taking a loss, but they are still doing better than the negative 300 that they would have gotten had they shut down. If we compare the price of 70 to the average total cost, we can see that the price of 70 is below the minimum point of the average total cost. In this case, that was 100. That's a quick way to see that we are going to have to take a loss here. Assuming this is not a seasonal effect, and the price is consistently below the minimum of the average total cost, then this firm would rather not be in this market. Negative economic profit means they could be doing better doing something else. In the long run, they will want to exit the market, but in the short run, they're going to have to do the best they can by minimizing their loss. We can see from these examples that as we change the price, our firm is going to produce different quantities. As the price gets higher, they're going to produce a higher quantity. And this is where the supply curve comes from. In the next video, we're going to continue looking at more examples of profit maximization in perfect competition.